Okay, let's go ahead and figure out this nice little math word problem here. And the first step to solve any problem is to read the problem. So let's go ahead and do that now. It says, how many seconds will it take a car to do one lap around a 2 mile wide circular loop traveling at 85 miles per hour? So, if you think you can do this problem, go to put your answer into the comment section and feel free to use a calculator. But here's the thing, if you're looking at this problem and you come to the immediate conclusion, and basically you're saying it's impossible that I can do this problem. I just read the problem. There's no way I could do this problem or figure this out. That's not a good approach to try to improve in mathematics. You should always attempt a problem, even if you're not going to get it right, because what you're going to do is kind of figure out you're going to see what you know and don't know. You're going to figure out what you need to work on. Okay. So even if you're not quite sure what to do, just do something with this problem if you want to fully participate and get the most out of this video. And hopefully that's the case. But, anyways, I'm going to walk through the solution step by step here in a second. Matter of fact, I'm going to show you the correct answer in just one moment. But before we get going, let me quickly introduce myself. My name is John. I'm the founder of TC Math Academy. I'm also a middle and high school math teacher. I've been teaching math for decades. I absolutely love teaching mathematics. I'm going to tell you right now, all of you can be successful in math, and I'm especially speaking to those of you that struggle in math. If you failed math before, or if you're having a tough time right now, all of this can be turned around. There is no such thing as a bad math student. Okay, I'm telling you right now, if you think you are bad at math, that is not correct. Okay, to be successful in math, you need basically three things. One, you need a desire to want to learn math. You got to be willing to do the work. So if you don't want to learn math, you're not willing to work hard. Well, listen, you're gonna have a tough time learning anything. The second thing you need is some encouragement. You need someone kind of telling you you can do it. Okay, and I'm telling you, you know to stay motivated, don't give up. All right. So you need encouragement. But the most important thing you need to be successful in mathematics is great math instruction, right? Clear and comprehensive and understandable. So when someone's teaching you something, you actually understand what's going on. So if you need help in your current math course or maybe some sort of special test that you might be getting ready for, something like the GED, SAT, ACT, GRE, GMAT, ASVAB, maybe teacher certification exam, anything with a math section on it. Or if you're homeschooling mathematics, check out my math help program. I'm going to leave a link to it in the description of this video. I literally have over 100 plus different math courses that span all these categories and much, much more. Extremely comprehensive courses that will really help you out. Also, I'm going to leave links to my notes in the description, my math notes in the description of this video as well, because so many of you out there have not been taking comprehensive math notes. That's really at your detriment. If you want to truly understand math and learn math, you have to take great math notes. So you can use my math notes right now, but you need to work on your own notes. It's really one of those things that a lot of students overlook. Don't do that. Take great notes. And if this video helps you out, don't forget to like and subscribe, as that definitely helps me out. Okay, so let's go ahead and take a look at the answer here. So here is the answer, 265.9 seconds. Okay, so now let's go back up here and just make sure we understand the problem again. So what are the first three steps to solve any math word problem? Okay, well, it should be almost any math problem, but let's just kind of keep it to math word problems here. The first three steps is to read the problem, reread the problem, and then read the problem one more time. Now, that sounds kind of funny to say, right? You're like, boy, I don't have to read things multiple times to understand what's going on. Well, there's a lot of information here, and you do want to reread things and really be very clear on what the question is asking. So let's go ahead and read it one more time. So we have, how many seconds will it take a car? Okay, so we're looking for how many seconds, right? How many seconds for what? Well, we have some car, and this car is going to do one full lap around a 2 mile wide circular loop. We can interpret that as a circle, and it's going at 85 miles per hour. Now, for some of you out there that might know some advanced physics and things like that, science or engineering, of course, these math word problems are overly simplified, so you never want to look, further into the problem. Like, hey, well, the car is going to be accelerating, but this couldn't happen. This can't be, realistic. Well, no, you just distill this down into a nice simple problem. But anyways, uh, this particular answer is an approximation. In other words, if you were kind of close to this, maybe you got 267 seconds, etc., I would accept that answer, but you should be in this ballpark. Okay, so how did you do? If you got this right, okay, if you're pretty much close to this number right here, well, let me go ahead and give you a nice little happy face, an A plus, a 100%, and a few stars to celebrate your success in mathematics today. Nice job. All right, so let's go ahead and get into the solution to this problem. And the way I'm going to approach a problem may not be exactly the way you approach the problem, but here's the deal. Anytime you're doing any math word problem, you need to justify your results, right? Just don't, if I asked you, explain to me how you got your answer, and you told me, well, I just kind of did it all in my head and my calculator, I just kind of reasoned it out, and then, this number popped out. Listen, that's not good enough. You need to always structure your conclusions in mathematics. So anyway, so we read the problem once, we know what we're looking for. So the first thing you want to do in any math word problem, after you read it a few times, you truly understand what the question is to model the situation. Now, oftentimes, like a sketch, a figure, or maybe creating a table, you need to some sort of way. And this is not the case with every math word problem, but most math word problems, you can find some sort of visual way that represents the problem. So what I've done, again, hopefully you kind of see what's going on, is, come up with this little sketch right here. So here we have a circular loop, all right, i.e. a circle. Okay, that's what we're going to just interpret that or assume that's what it's talking about. And we have this car. It's going to do a lap, okay, around this circular loop at 85 miles per hour. And we know that the circular loop is what? It's 2 miles wide. Okay, so we have a 2-mile wide circular loop. We know the car is going 85 miles per hour, and it's going to be going around this loop. And we want to know what? What do we want to know? We want to know how many seconds, okay, is it going to take this car to do one complete lap around this loop. So that's basically what's going on. And again, when you look at the problem this way, you can say, okay, I'm dealing with what? Well, I'm dealing with a circle, all right? So I'm dealing with a circle, and I'm dealing with speed, okay, and distance. So here I have speed, and here I have distance, and here I have a circle. So you have to be thinking to yourself, how can I tie in all these concepts? Well, let's go ahead and take a look at how we can do that right now. Okay, so here's the thing. What we really want to know is the following. We have a car. This car is going 85 miles per hour. We want to know what is the distance this car is going to be traveling around this circle, okay? Now, it's going around this circle, but this could be, like a straight line as well, because it would be effectively the same question. So the thing is this, we need to know what is the distance around the circle, okay? Well, that is effectively called the circumference. Okay, the circumference is the distance around a circle. So once we kind of understand, hey, we want to know the distance around a circle, i.e. the circumference, we need to now think about what is the formula for the circumference of a circle. And there's a ton of formulas in mathematics and algebra, geometry, but some of these formulas, I would say most of the formulas that you learn in mathematics, I'm talking about middle school, especially high school, most of the formulas you're not going to retain into your long-term memory. There's no need for it. That's why you have to take math notes, okay? So, if you want to look up a formula, you go into your notes or you go, onto your computer and you look up, on the internet what the formula is for whatever you need. However, there are some formulas that you should have in your long-term memory. Okay, i.e. you should just kind of have them built into your brain, and you should be able to recall them. I'm going to suggest to you that the circumference of a circle is one of those formulas, okay, along with things like the Pythagorean theorem, and there's a few other formulas, but some of these formulas you should be able to recall upon without looking at your notes, okay? And then I'm going to suggest that you try to retain this. But anyways, if you forgot, okay, what the formula for the circumference of the circle is, it is equal to the diameter times pi. Another version of that is 2 pi r 2 times the radius times pi, which is the same thing as the diameter times pi. Now, the diameter is, in fact, the width of a circle. Okay, that is how wide a circle is in fact the diameter. Okay, so we know that we have this circular loop that is 2 miles wide, i.e., the diameter is 2 miles. Okay, so now that we understand kind of the situation, but let's go ahead and compute the circumference. So the diameter is 2, so we're going to plug in a 2. We know we're dealing with miles here. So the circumference is 2 pi miles. That's the distance around this particular track here, this circular loop. However, I don't want this right here, 4 pi miles, is the exact distance, but I want to kind of have some sort of approximation. So if I said, hey, how far are we going today? We're going to go 4 pi miles. Well, most people are going to want some sort of, decimal value or, some sort of a better approximation. So what we're going to do here is take our pi value, okay, and we're going to substitute in 3.14, which is a very, very rough approximation of pi. So anytime you want to have an approximation when you're working with pi, like the area of a circle or the circumference, here's the thing. So here you have pi. The exact answer in terms of the digits of pi, this goes on to infinity. It's impossible to do it because this is what we call an irrational number. So the digits of pi are like 3.14, I think it's 15, I'm not quite sure. There's some people out there, they actually have competitions on this, and I don't even know who the world record holder is because this kind of changes almost year to year. But there are people who know hundreds and hundreds of digits. They've memorized hundreds and hundreds of digits of pi. It's pretty crazy. So you don't need to do that. What you need to know is that pi at a minimum is equal to 3.14. But the more digits we use, because the digits go on and on and on, they do not repeat and they do not terminate. Okay, that's the whole idea behind what we call an irrational number. So we just use this symbol to say, hey, you know what? All the infinite digits here, we're just going to use this symbol to represent that. But if we want an approximation, okay, we don't want to use the equal symbol. Okay, we're not saying pi is equal to 3.14. You could say pi is approximately 3.14. So that's like the most kind of basic estimation of pi that you'd want to use. And the more digits of pi you use, the more accurate your answer is going to be. So technically right here, I'm saying the circumference is equal to 2 times 3.14. Really, let's fix that up and put in the approximation symbol because that is really more technically correct. Okay, so the circumference is going to be equal to 2 times, not pi, we'll approximate 3.14. So 2 times 3.14, again, don't feel shy about using your calculator, is 6.28 miles, okay? All right, so now we're looking at the situation. This car is going to be going, we want to know how many seconds is it going to take the car to travel 6.28 miles, which is effectively the distance around the circle at 85 miles per hour. Okay, so again, this is kind of now the question we really need to answer the overall question of the problem. How many seconds will it take the car to travel 6.28 miles going 85 miles per hour? All right, so now we need to be talking about units of measure. This is miles per hour, okay? But we want to know how many seconds. So anytime you're dealing with units of measure, miles and feet, seconds, hours, minutes, you need to be on high alert to be working with the correct units of measure in the problem. Okay, this comes up over and over again, especially in math word problems. But let's go ahead and take a look at the formula you'll need to figure this out. Now, you could use a proportion to solve this problem, but I'm going to suggest to you that you know this formula by heart. This is another one of these like super important formulas in mathematics and in physics and things like that. And it's basically this: rate times time is equal to distance. Okay, rate is effectively speed. Okay, time is obviously time is equal to distance. So the rate of the car, if the rate of the car is given to us i.e., when you hear rate, velocity, speed, they mean the same thing. So if the rate is in miles per hour and we're given our time in hours, in other words, a car is going 60 miles per hour and it travels 1 hour, okay, 60 miles per hour times 1 hour. What was the distance that car went? It went 60 miles, okay? So here we're in miles and hours. Our time is in hours and our distance is in miles per hour. So our time is has to be the same as this unit right here in terms of our rate and the distance as well. So if they are not the same, we're going to have to convert some things around. But we'll handle that here in just a second. But anyways, this is the formula that we want to use is rate times time is equal to distance. So what is the rate here? Well, the car is going 85 miles per hour. How many seconds is it traveling? Well, I don't know. Okay, let's figure out how many hours it will take for this car going 85 miles an hour to travel a distance of 6.28 miles. So we know this, okay? We know this. This right here, time, we don't know. Okay, so that'll be our unknown. So let's go ahead and plug in what we have and solve. All right, this is where our algebra skills are going to come in. So 85 times x, and x is our unknown amount of time. 85 times x is equal to 6.28 miles. We kind of drop the units of measure right now. Let's just do the algebra and solve for x. So how do we solve for x? I'm going to simply have to divide both sides of the equation by 85, and you get x is equal to 0.07388, and there's more decimals, but we'll just stop right there, 0.07388. Now this is where you have to be on high alert in terms of what you just solved for, okay? If I just plugged in 85 miles per hour, if the car went 6.28 miles, what is the unit of measure I'm solving for? I'm solving in hours, okay? So this is miles per hour, this is miles. So my time when I solve for this will be hours. All right, so it took this car 0.07388 of an hour, okay, or hours to travel 6.28 miles at 85 miles per hour. But the question, okay, is not how many hours this took this car to go, it's how many seconds, okay? So now this is the whole idea of rereading the problem again. I've seen millions of students, maybe not millions of students, certainly certainly tens of thousands over my decades of teaching. You lose track over the years, but I've seen it over and over and over again where students are so excited they'll write this down as their final answer. I'm like, oh, you're not looking at the question is saying how many seconds. So before you get excited and do some work and turn that in and be like, here's my answer, think about what is the question asking. Seconds, right? So now we have to convert 0.07388 hours into seconds. So how do we go from hours to seconds? Okay, well, let's talk about that right now. Now, a lot of you can just reason through this. You're like, okay, hours, seconds, there's 60 minutes in 1 hour, and there's 60 seconds in 1 minute. So you can kind of figure that out this way. But I'm going to suggest to you that you need to be really good at working with what we call conversion factors. Okay, and here's an example of a conversion factor right here, actually, two. So if you want to go from hours to seconds, here's what you want to do. We have two conversion factors that we're going to need to use. Let's take a look at both of them right here. So let's go from hours to minutes and then minutes to seconds. So what you need is, again, something called a conversion factor. We need to multiply hours by a conversion factor. A conversion factor is simply just a fraction, okay, where we have one of the units that we're trying to convert to the next unit we're trying to go to. Okay, we're trying to go from one unit to another unit, and we need to put both of those into a fraction. So instead of going hours to seconds, let's go from hours to minutes, and then we'll go to minutes to seconds, all right? So let's make a comparison. So we know 60 minutes is to 1 hour. 60 minutes to 1 hour, right? So that's one conversion factor. Now, when I look at this, if you think of, I could say, well, 60 minutes is to 1 hour. Why can't you just put it this way, 1 hour to 60 minutes? That is also a correct conversion factor. You can either use this one, where the hours in the numerator or the hours in the denominator, but why am I using this one here? Well, here, 1 hour, if I put this over 1 as a fraction, and I'm looking to cross cancel the units, I'm trying to go away from hours. So I need an hour in the numerator and the hour in a denominator so I can cross cancel. If I had this one right here, where I had an hour in the numerator and an hour in a numerator, I would end up with this, an hour times an hour. I would end up with hours squared, okay? So when you're working with conversion factors, you have to be really, really careful on which one you're using, and just look to see to cross cancel these units of measure. One of the units in the denominator and one in the numerator. So these cross cancel. Perfect. So now 1 hour is how many minutes? Well, 1 times 60, 60 minutes. Now I want to go from minutes to seconds. So I can use this conversion factor, not 1 minute over 60 seconds. I want to use 60 seconds over 1 minute because the minutes will cross cancel. So how do I go from hours to seconds? Well, it's going to be 1 times 60 times 60. Let's go ahead and take a look at the final answer right here. Okay, so to go from hours to seconds, this is the way you would want to do it. We have 0.07388 hours. Okay, the hours will cross cancel right here. So 60 minutes per 1 hour. Here, the minutes will cross cancel, and I'm left with my final unit of measure, seconds. Okay, so if I take this 0.07388 and I'll multiply by 60 and then multiply by 60 again, or multiply by 360, you're going to get 265.9 seconds. Okay, so this is how you do it. Now I know I kind of gave a really, detailed explanation of how to work with conversion factors, but this is extremely important. All right, if you kind of reason through, and a lot of you could have just used some common sense and said, "Oh, I already knew how many seconds were in an hour." That's, I'm not saying that's not good that you understood that, but you also need to know how to work with conversion factors, because I can give you much more sophisticated units of measure. And this really comes up when you're doing more complicated problems, especially in science classes like physics and things like that, when you're working with acceleration, velocity, and, remember, math is a language of what? Well, math is a language in and of itself, but it's also the language of science and so many other things. But I can tell you right now, when it comes to solving math and word problems or algebra word problems, it's very, very common that you're going to have to do some converting of units of measure. Okay, so hopefully this little problem helped you out. If you're looking to improve at doing math word problems, whether they're algebra word problems or not, let me give you a couple suggestions. One, I have a ton of videos on my YouTube channel with various word problems, but really, word problems are in every level of mathematics. So if you're at a kind of basic level, maybe a pre-algebra level, well, check out my pre-algebra course. I have pre-algebra level word problems in there. If you're in a pre-calculus level or an algebra 2 level, obviously you're going to be doing more challenging and advanced word problems. But the only way you're going to get better at any thing in mathematics is to practice, practice, practice. Even this particular problem, if you're just watching it, and you're like, oh, I could do this. Well, you're not sure if you could do this or not. If you really want to validate whether you comprehend something, try to come back and do this problem maybe in a day or two, right? If you write it down without looking at me, doing the solution, and see if you can get the answer again. That's a pretty good way to test your kind of long-term retention. And that's really what math, to get better at math. If you're learning math but you're not retaining it, then you're not going to get better at math. The whole key is retention, and that's why note-taking is so important, because note-taking definitely helps you with retention. All right, so with that being said, I definitely wish you all the best in your mathematics adventures. Thank you for your time and have a great day.